Assalamu alaikum, A2s. How are you people? Hope everything is fine there because I'm really tense today after hearing all the news from all over the world. I'm not 100% telling you honestly. Anyhow, we have to do the work and as you know, you guys have had your mocks, I've checked them. So the first paper that I'm going to review with you guys, that is your P5. Most of you had problems with this statistics paper, okay? So let me do the first question for you guys, okay? By the way, this paper was actually 06, like paper 6 from May, June 07, okay? So you can have its copy. Just to see that what are the actual statements of these questions. Okay. Now the first question was basically from the concept of the coded data, and we used to call this as the assumed mean method. Okay. We were given n as 12. I'll read out the question later on. Let me just note down the given information. The sigma t minus 35. This marker is not really good. This is minus 15. And then sigma, this is t minus 35 whole square, that was given 82.23, and is asking for the mean and the standard deviation of this data. Now I'm just going to read out the question. It says the length of time t minutes taken to do the crossword in a certain newspaper was observed on 12 occasions. So that is why I've taken this n as 12. Okay, so sigma t minus 35 was minus 15, and sigma t minus 35 whole square, that is going to be 82.23. Now this question, solving this question really becomes easy if you change this t minus 35, let's say with y. So this is going to be t minus 35, that is in fact this is going to be your y over here. Okay, so now this sigma y is minus 15, this sigma y square is 82.23, and basically you have to find the mean times from changing the symbol from x to the t. Okay, so now this is your coded data, the new data. Basically these were the times, so we have taken out 35 from all the times, so is your assumed mean is 35. Okay, so now this is sigma y, this is sigma y squared. If you want to recall that thing that I told you about this coded data, so I'm going to tell you just with the easy example once again. Now suppose you have 10, 11 and 12. These are the values of x. Now you want to find the mean. So you assume that the mean is, let's say, 10. So that is your A, which is going to be 10. Now you will find the new data, that is going to be x minus A. You will take out 10 from all these values of x. So the new data would be 0, 1 and 2. You can see that the difference between this 10 and 0, 11 and 1, 12 and they are all 10. Okay, so now the mean of these three values, you can easily find the 0 plus 1 plus 2 over 3. So this is going to be equal to 1. So that is the mean deviation basically. Okay, so if the mean of this data is 1, you can find the mean of the original data by adding that 10 back into this data. So this x mean, that is going to be this d's mean plus a. That is how we have done this in our class. Okay, so this is going to be this 1 plus this 10. So the actual mean is going to be 11. Okay, the second thing is about the standard deviation. You guys know that if you look at the spread of this data, you look at the spread of this data, this is like the difference between this 10, 11 is same as the difference between this 0 and 1. The difference between 11 and 12 is same as the difference between 1 and 2. Therefore, the standard deviation of the original data or the standard deviation of the new data, they are going to be absolutely the same. So I'll be applying this thing over here. Okay, now in this situation, your A is basically this 35. We have taken out 35 from all the values of that t, as we did here, like as we took out 10 from all these values of this x. Okay, so we can find the mean, the new mean, through this the mean of this y is going to be sigma y over n, that is minus 15 over 12. Okay, so this minus 15 over 12, I can find this minus 5 over 4, this is minus 1.25. Okay, now the original mean would be, you will add this 35 into it, this is minus 1.25 plus 35, and that will be 33.75. that is the mean over here, okay, the required mean. And now we have to find the standard deviation. So as I told you that the standard deviation is going to be same for the actual data or for this new data, the coded data. Okay, so you can apply that formula over here, that this standard deviation is going to be square root of, I can use this sigma y square over n and minus this mean square, the mean of this. Okay, so this standard deviation is going to be the square root of this 82.23 over 12 and minus this mean has to be used over here. Okay, this is minus 1.25 square, so this will give you I think this is something 2.3 kind of a answer. Okay, so this was the first question. I believe that I'm going very fast, so you can, like, watch this video again for this first question. Okay, if there are any questions, you can let me know. Okay, now the second question, moving on to the second question of this paper. It says Jane is equally likely to attend or not to attend a training session before a football match. So since there is a requirement, we have to draw the, this is attending, not attending. I'm going to draw the tree diagram. So this is equally likely, so I'll be writing half over here, and I'll be writing, so Jane is equally likely to attend the training session before a football match. If he oh, I'm sorry, this is not Jane, this is my eyes, this is Jamie. Okay, Jamie. These names are very difficult. I'm sorry, I can't pronounce them. Okay, I'll call this Janu, okay, instead of Jamie. So now Janu, if he attends the, if he's certain to be chosen for the team which plays, like if he attends, so here he is attending, so chosen, that is going to be 1, not chosen, that is going to be 0. Okay, Janu. Now this Janu has a chance of 0.6. If he doesn't attend this training session, that is going to be 0.6, and this is going to be 0.4. Okay, so it says find probability that Jamie is chosen for the team. So he can be chosen if he attends or if he does not attend. So this is going to be the first part, the probability of being chosen, that is going to be AC, probability of AC plus probability of A dash C. Okay, so this is half times 1 plus half times 0.6. So I'm writing this as a decimal, this is 0.5, this is 0.3, so this is going to be 0.8. There is a probability of 0.8 that Jamie or Janu is chosen for that football match. Okay, now, so this is purely your, there's nothing like A-level thing over here. This is just a typical O-level probability question. Okay, so there was nothing difficult. Many of you were able to solve this, by the way. Now in the second part, it says find the conditional probability that Jamie attended the training session given that he was chosen for the team. Okay, so now I'm just going to keep it here, this answer. Okay, this is probability of being chosen. Okay, so he says given that he is chosen, find the probability that he attends that training session. So this is basically probability of A and C over probability of C. Okay, so we have to find the probability that Janu attends the this training session given that he is chosen. Okay, so this is A intersection C. He attends and chosen divided by all the cases where he is chosen. Okay, so this is going to be 0.5 divided by this 0.8. So that was the answer, 5/8, or as a decimal this is this is 625. Okay, so this was the second question. This was an easier question on conditional probability. Okay guys, moving to the third question. This was a very important question. This is from the normal distribution, I think. Yeah, let me see. The third question is from the normal distribution. Okay, now it says in the third question, the random variable x is normally distributed. He's himself telling us this is normally distributed. The mean is twice the standard deviation. Now you see, there are very difficult symbols for the mean and for the standard deviation. So you could have supposed that, let's say this standard deviation is x. Okay, so this mean was twice the standard deviation. If you had used these easier symbols, like many of you really tried it, but because of these nasty symbols, you guys just messed up the solution of this third part A. Okay, so it says the mean is twice the standard deviation. So the mean is twice the standard deviation. We just suppose that the standard deviation is x. Okay, now it says given that probability x is greater than 5.2, that is equal to 0.9. Okay, so I have to write here that let x is normally distributed. This is the mean and this is the standard deviation. Remember, we write here the variance. So I'm writing it as x squared. Okay, I hope you can see this. This is 2x, this is x squared. Mean and this is the variance. He's asking us find, like he's given us the probability that x is more than 5.2, and that is 0.9, and we have to find the standard deviation. So basically we will find our x. Okay, so I will be starting this by standardizing it. Okay, this is an easier topic, believe me. Okay, so this would become probability. Now instead of this x, I'll be writing z, that is for the standard normal distribution, and the toppers will write here let z is normally distributed with these. Okay, so you must mention this. Okay, now this let z like the probability that z is more than, so I'll be using this formula here. This z is equal to x minus mu over the standard deviation. Okay, so this is going to be 5.2 minus the mean, which is 2x, over this x, the standard deviation, that is equal to 0.9. So guys, you see this is greater than symbol over here, and this probability is more than 0.5. If you just recall that the normal distribution curve, okay, like the bell-shaped curve. Okay, now this is 0 over here, this area is half, and this area is half. Okay, so if you have more than something and the probability is 0.9, so where do you think, should that be before this 0 part or after the 0 part? Yeah, yes, what do you say? Okay, so it has to be over here, somewhere over here. Only then you see all this area is going to be 0.9. Okay, so by seeing this, you should be able to determine if this value is basically negative or positive. Okay, so as I showed you, this is basically a negative value. So we have to make it negative forcefully. Okay, so I'll take a minus common from here. This is going to be minus, this is 2x minus 5.2 over x, and this is equal to 0.9. Now do you remember that thing, there's a greater than sign and there's a minus, like if I write here when we have probability z is less than a, this is directly written as phi of a. When you have probability z is less than minus a, this is basically phi of minus a, which is 1 minus phi of a. And when you have probability z is greater than a, this is 1 minus phi of a. And when you have probability z is greater than minus a, if you look at all these things, you must be convinced that this can be written as phi of a. Okay, I'm trying to focus on the solution of this question, assuming that you guys have these notes with you. Okay, If you want to know its detail, I can have a separate session for this. Okay, now the greater sign, the minus sign, I can write it as phi of 2x minus 5.2 over x, that is equal to 0.9. Okay, so this 2x minus 5.2 over x, that is phi inverse of 0.9. So you solve this question. Okay, let me see if this girl has done this. Yeah, she has done this correctly. Here, yeah. So she has found the phi inverse of 0.9, which is going to be 1.282. Now the rest is just simply a linear kind of algebraic equation. You cross multiply this, you get your x, and that x will be the required standard deviation. Please do this question again and try to do the questions which are similar to this. You can find many such questions in the past papers. Okay, so I have to erase this. I have to go to the second part of this third question. Okay, now the third question was, again, this is from the normal distribution. Now there is a problem with this, many of you tried this and you use that concept. Let me just note it down. It says a normal distribution has mean mu and the standard deviation sigma. So let's say this is x is normally distributed with mu and this sigma square. If 800 observations are taken from this distribution, out of 800, so n is 800. Okay, how many would you expect to be between mu minus sigma and mu plus sigma? So it's asking that what is the probability that x is between mu minus sigma and mu plus sigma. Okay, if you remember that thing, the initial thing, initially when we started this chapter, I gave you the properties of a typical normal distribution. So the good students, they did remember that a normal distributions, 2/3 of the data lies within one standard deviation from the mean. Now this should be directly equal to 2/3, but I wonder the marking scheme doesn't support this. They are giving 3 marks for this. So we have to show the working. I'm sorry, we have to show the working over here. Okay, so the ones who wrote it equal to 2/3, they are just given 1 mark for this. Okay, so we shall show all the working to find this standard deviation. Yeah, the number of them which are within this range out of this 800. Okay, so I'll be writing it as probability, that is its working. Z is between mu plus sigma minus mu over sigma. This is mu minus sigma minus mu over this sigma. Okay, now this is we have to find this basically, that what is this. Okay, yeah, so this is, I'll be putting the equal mark over here. Okay, so guys, this looks so weird, but please see, I have simply applied the formula z is equal to x minus mu over the standard deviation. This is our x over here, so I have put it here. Okay, and this is the x in this case. Okay, and since we're not given the values of the mean and the standard deviation, so I'm just writing them as it is. Okay, anyhow, this now becomes, you see, this mean is cancelled with the mean, this mean is cancelled with the mean. So I have this, you see, now this sigma will be cancelled with the sigma. This is -1 and this is 1 left over here. So this will be phi of 1 minus phi of -1. Okay, so this is 2 phi of 1 minus 1. If you change this separately, this phi of -1 with 1 minus phi of 1, so you can get this thing. Okay, so now you have to find from the table the phi of 1, which is 2 into 0.8413 minus 1, that is 0.6826. Okay, so we had to tell that how many of the of this 800, they lie between this. So you multiply this thing, this probability with 800, and that will be the final answer. That is 800 times 0.6826. That is 546. Okay, this is the answer. The third question. I'm taking a break here. Okay, I'll come back with the question number 4, 5, 6, and 7. Thank you very much.